All right. Hello, everyone. My name is Moritz. In the past, have been a security researcher focusing on application security, and since almost 3 years now, I work for a German startup called Edgeless Systems, and we build open source software for a new technology called confidential computing. Has somebody of you already heard of confidential computing before? Maybe raise your hand. Couple hands. It's a topic that gets more and more popular in security space, but also finds its way into the cloud native world. And this is pretty much what we focus on. And our flagship product, if you will, is called Constellation. But I don't want this to be like a product pitch and focus more on giving an introduction on confidential computing, how this can be applied into the cloud native Kubernetes world, and then use Constellation as an example and maybe show a demo if we have time. So the threat model that, at least the way we apply it, confidential computing focuses on is not the usual front door vulnerability in your application or in your dependencies that an attacker might use to get access to your application and your data. Instead, the threat model here is the threats that come through the infrastructure. So especially in the cloud world, where we share a lot of infrastructure, where we run essentially on other people's computers, the threat of the infrastructure is becoming more of a thing. That could be another tenant on the same cloud provider that might use vulnerabilities in the infrastructure in some cloud services to escalate privileges, to cross-tenant attack you. But that could also be somebody that already has access, like a cloud administrator or somebody that works at the data center. And that doesn't necessarily need to be somebody that's malicious. It could also be somebody that's just compromised, right? It's all humans. They all have some form of credentials, and somebody could steal them and gain access through their credentials. And finally, probably not as relevant for most of you, but also a concern in the world of cloud computing. There might be state actors that have direct access, or they gain access to the cloud infrastructure and have access to your data. And these are not just potential or theoretical threats. With the more and more adoption of cloud computing, we also see a lot of focus shifting towards attacking that infrastructure. Right? There are a lot of vulnerabilities discovered in the actual cloud services of the cloud providers. There's examples of privilege escalation via container escapes or similar attacks. There are these cases of lawsuits against cloud employees. Of course, these are not as prominent in the news than other things. But these are actual threats that we're dealing with. So the question is, how can we protect such powerful attackers that have access to pretty much everything in the stack? And the solution with confidential computing pretty much builds on two properties. So as I said, this is a hardware extension, a new hardware technology that found entrance into the processors, into the CPUs. This is also soon coming into GPUs and other types of processors. But essentially, the two properties are runtime encryption. So between encryption at rest, so when you store something on disk, and encryption in transit, when it flows through a network via, for example, TLS, there's this new feature that encrypts the main memory and isolates certain parts of that main memory. So, for example, your container, your process, your VM. And the other thing, and that's equally important, or maybe even more important, is the remote attestation capability. That means you can verify that something is encrypted, and you can verify its identity remotely just based on the processor itself. So the processor is able to provide you with a certificate, with a report of what's being running there and that it's being isolated and encrypted. And these two things together are very powerful and allow to create a trusted space in the cloud where you can move your data and your workloads, and they are not accessible but from anything else in the infrastructure. So the latest generation of hardware pretty much implements that as a virtualization technology, so that the isolation cut is essentially a VM. So you can create a VM that is, its entire memory is encrypted, and the VM is isolated against any access from any other part in the stack. That's your host OS, your hypervisor, that's direct memory access, or even a data center employee that might pull out the RAM and try to do extract the secrets from there. So anything below that VM boundary is not able to access that. And the processor takes care of doing that encryption and that isolation of memory. And this concept of a confidential VM, an isolated encrypted VM, was probably first introduced by AMD, called with AMD SAV a couple years back. Now Intel has followed suit and introduced TDX. Some of you might be familiar with from maybe SGX. That's probably more popular. It was, wouldn't say the predecessor, but in terms of confidential computing, maybe the predecessor to that. TDX is now also VM-based. And then there's a architecture from ARM called CCA, or there's also a RISC-V specification for a similar concept. And they all work more or less the same, right? They have some differences, but essentially they isolate and encrypt entire VMs. Any questions so far? Anyway. All right, so that's a technology that's available in hardware today, right? You can buy a chip from AMD, from Intel, that has this technology included. You can enable it, you can use it. So the question is, how would you use it? Today, most cloud providers have a confidential computing offering, so you can go to Azure, GCP, or any other major cloud provider, and you will be able to create a confidential VM, basically as infrastructure as service, and then use it for deploying your application and data. But infrastructure as a service, VMs are probably not the usual type of abstraction layer we're dealing with in the cloud native world. So the next part I want to focus on how we bridge the gap here, right? How do we enable our applications, our containers, to consume that and run encrypted at runtime in the cloud? So given we have such VM or such hardware with this capability, for example, SEV or Intel TDX, the most natural thing, or maybe the first thing that comes to mind, would be, since if we're not running bare metal, our Kubernetes, usually the Kubernetes nodes are VMs. So why not just run a Kubernetes node inside a confidential VM instead of a regular one? So we boot up our node image inside such confidential VM. That means all of the Kubernetes components, the kubelet, the container runtime, also the control plane, if you run your control plane as well in confidential VMs. All of this runs inside such environment, and then we can just deploy our applications inside. So we schedule a pod with a container in such VM, and it's automatically benefiting from these concepts. So it's automatically runtime encrypted and isolated from the rest of the stack. So this I would usually call a confidential node. And the other concept, or the second way I would imagine, or I see how things are going to be applied, is, let's say the node, we just use a regular VM, and then we use a concept that is probably known from the Kata project, Kata container. Somebody has heard of Kata? It's a CNCF project before. So the idea is run every pod as a VM. Why would you do that? Because you don't trust the container that's inside, and you want to protect your host from whatever's running in that container. So it's not as easy to escape that container and might get access to your host. And now we can take that similar concept and turn it around to protect our container against the host. There's some adjustments, and basically out of the Kata project, there's a new project that's now a CNCF sandbox project, is called confidential containers. That takes this concept and isolates individual containers using confidential VMs inside your node. That can be based on nested virtualization, or there's another concept. It's called peer pods, but I'm not going to go into the details. Essentially, you isolate your containers. And both have their right of existence, and they have their pros and cons. And now look a bit into what these pros and cons might be. And I start with the right-hand side, with the confidential containers project. confidential containers concept. So let's assume we want to deploy our applications, and we deployed our containers using confidential containers. No modifications to the container necessary. You just basically deploy a container in runtime and a controller, and that takes care of booting a container inside a confidential container. And let's assume we don't have one golden container that does everything. Our application is a typical cloud-native microservice architecture, so there are different services that work together to build your application, like a front end and some back end. So now the question is, what are the challenges, right? Our containers are now encrypted. I can potentially verify them using remote attestation. Should be done, right? The challenge here is that I don't trust anything other than the container itself. So the challenge with this is now, how do I connect to this application? How do I know this runs in confidential containers and not just any other container? How does the front end know when it connects to the back end that this also runs in a confidential container, right? So how does the identity and the authentication work? How do I configure my container? If I don't want to burn everything inside that container and make it basically self-contained, right? If I want to use my usual ways of deploying applications in Kubernetes, how do I do that? Because I don't trust the API server. I don't trust the kubelet. They all don't run inside this confidential boundary. So if I put a secret there, if I put let's say, something in my YAML file saying this environment variable should end up in the container, whoever has access to the API server just can change it, and I have no way of verifying. So all of these are challenges I need to solve. So essentially, you can break this down as I want secure connections between my containers. So MTLS is something we know out of the cloud-native world. I want that between all of my confidential containers. And then I want attestation. I want one container to base the identity or to authenticate another container solely based on remote attestation. And the same I want for the client side. And for the client side, I don't want only to verify the front end. For some reason, I also want to know that the back end is secure and that entire deployment is secure, and it's not just somebody deploying a valid back end that then connects to some malicious, deploys a valid front end that connects to a malicious back end, right? I want to verify the entire pipeline here. And finally, I want a form of orchestrating that. I don't trust the API server. I don't trust anything other than my containers. So I need some trusted party in the control plane, in the orchestration, to take care of these tasks for me. For example, to provision secrets, to provision configuration, to maybe update a container version in a secure way, so I don't have to manually authenticate and verify that process. So essentially, orchestration is missing here. And there's an open source project we do that's called MobRun that essentially implements the challenges I've just shown, right? By more or less implementing a trusted controller, or you can also say sometimes service mesh maybe, if you want to use that term. You can verify the controller itself. It runs inside, again, a confidential container, and once you've verified that controller, the controller takes care of basically bootstrapping the rest, taking care of all of these challenges of authenticating the individual containers and establishing secure connections between them. So with confidential containers and MobRun, you get confidential deployments. And then you have a very small trust base. If you deploy something that to the cloud, you essentially trust the minimal stack inside the confidential container. You trust your container. You trust the controller. And with trust, I mean, of course, you can verify. But after verifying, you trust that setup. And this is all of the components you have to trust in that environment. Don't trust any other part in the cloud anymore inside that cloud infrastructure. And that's pretty cool, but it has a little bit of overhead. You have to deal with these additional tasks. You have to think about how MobRun works or whatever tool you want to use. You have to configure it, so there's a bit of adjustment needed. It's not straight lift and shift. But if you deploy some new types of applications, if you maybe have a very sensitive application, this is a cool concept. And more or less, this kind of concept is used in Germany, for example, for the health records. that's currently being rolled out. Some similar concept to that. So going back here, that was the right-hand side. Going back to the left-hand side. So as I said, difference being instead of protecting individual nodes, we protect our individual containers, we protect the entire node, and then just shift everything inside. So what are the challenges here, right? If I just take all my nodes and I put them into confidential VMs, I have similar challenges, or I'm facing similar challenges, just on a different level. Instead of on the container level and on my deployment level, I'm facing them at the Kubernetes and the node level. So how do I authenticate the different nodes? How do I establish secure connections between them? How do I verify this entire cluster from the outside without dealing with all the different nodes? How do I deal with storage? So again, I made us a quick summary here. I want secure connections between my nodes, and then I want authentication identity based on remote attestation again. I want to encrypt the edges. That means my storage, my network. And then similar to as with the deployments, I want this to be operational and maintainable. So you can summarize this as state 2 operations. Somehow I want to verify this once, and then I have a secure way of upgrading, let's say, the Kubernetes version to the next, updating the node images to a new version, and doing that in a well-defined way, so that if I verify this once, I know exactly what kind of transitions I have, and this always stays in a good and verified way, so that the cloud provider or anybody else could not just exchange a node, join a node that doesn't run inside a confidential VM, man in the middle, the connections between my nodes, stuff like that. That should not be possible at no time. And this lifts these individual nodes to an entire cluster. So the first one was basically coming from confidential containers to confidential deployments. This brings confidential nodes to a confidential cluster. And then from there, from the inside, it's more or less just lift and shift, right? Inside that, it just runs Kubernetes. There's no difference. So you can use anything you used before. You can just lift and shift your deployments. And this is the big upside. So the confidential computing aspect here is almost invisible. Of course, if you want to audit, you can always audit. But from a day-to-day usage of that, there's no difference. But from the outside, this is protected and verifiable as a whole, as a one concise context. And yeah, since the talk is called Constellation, Constellation pretty much implements this concept of a confidential cluster. So it takes confidential VMs as nodes, pretty much tailors all the images to be immutable, be verifiable, brings them all together into a cluster that can be verified based on these remote attestation capabilities of the hardware itself, can be verified as one concise cluster, and then can be used as a carve-out, as a private space in the public cloud to deploy applications that are runtime encrypted, that are verifiable. And this runs everywhere where you have confidential VMs. You just need the hardware. And yeah, you can also do it on-prem with OpenStack currently. I can show a quick demo because we have a bit of time left. Right, so Constellation can be deployed different ways. There's a CLI tool. That's probably the easiest and the fastest way of getting started. But of course, you can use infrastructure as code such as Terraform to do the same. And the workflow is pretty much always the same. You create a config, and then you pretty much apply that config and deploy it to your cloud. And then let's say you want to upgrade something, you upgrade that config, and then this upgraded config is again applied to your running cluster. So let's see this in action. I can say Constellation. I already have the. Oops, you don't see my terminal. No. Yeah, this is just the VS Code for demo purposes here. I already installed the CLI tool to do that. You can supply chain verify that so that it's actually the CLI tool that we built and published, and you have signatures for that. You can reproduce the build if you want to be or if you're very paranoid. And then you have the exact same CLI tool or you can verify that you have the exact same CLI tool locally. So as I said, you can create a config generate for your favorite cloud, let's say GCP. And this creates a YAML config file pretty much of describing what my cluster should look like. Let's say which Kubernetes version, which image version, and then some cloud provider specifics. I'm not going to go into all the details in this demo now, but it's all up in the documentation if you're interested. And once you have this config and filled in the cloud provider specifics, like what region, what zones, and so forth, I've done that ahead of time. So here I have a config that has all of these information already inside. And then all I have to do is say provision a cluster based on this configuration. And I say Constellation config Constellation create. And I tell it to start off with one control plane node, 2 worker nodes. Probably not something you would do in production with just one control plane node, but this is the fastest way of creating a cluster here. And then this will go ahead and provision the infrastructure inside GCP, basically telling GCP, hey, boot up these machines, these VMs as confidential VMs, so in this case based on AMD SCV, and use this image. And once everything is up, this prompt will return to us and say, well, now infrastructure has been provisioned. And then comes the interesting part where we say, okay, now that the infrastructure is there, now let's verify it. And verifying meaning basically verifying all of the nodes that have been booted, so the one control plane node, these 2 worker nodes. And the way and this works in Constellation is we always verify the first node, and then the first node gets provisioned the ground truth or the configuration on what we want to verify, and then it verifies the rest. And this is then continued during scaling events of that cluster. So we only need to do that once, and we know by transitively verifying the first node and knowing the first node is a good node, we know that it verifies all the other nodes based on the same information. The way that the verification works, as I said, is based on remote attestation, and remote attestation is something that the processor extension gives us, the new confidential computing capabilities. So the processor gives us a signed statement that says, this was a confidential VM and booted that image based on these hashes. And the hashes correspond to all the components that run inside that VM. So it starts from the firmware, bootloader, kernel, and so forth, up to userland. And the ground truth on what this is compared against is inside this configuration file here under measurements. So all of these hashes correspond to one component inside that VM that we booted. So once we retrieve that statement, we verify the signature. It was signed by the CPU. There's a PKI going back to the hardware vendor, so in this case AMD. So we verify that this is actually a valid signature from an AMD processor. And then we check the content, and inside the content we verify all these hashes, and then we know exactly this was a Constellation image version, blah, 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 with exactly these components. And then I can go back, and if I want to, I can reproduce these components again using reproducible builds. So I can, by code line, verify all of these components that run inside that node. And of course, the node is immutable, so there's no chance of being changed, and it's encrypted, so it's everything that's stored inside that node is also confidential. Long story short, in the end, I'm provided with a running cluster. Since I don't have that much time left, I'm not going to go into all the details here, but essentially you are then provided with a access configuration for this cluster. Maybe you can scroll up a bit now. And I can use that to, for example, show all the nodes using kubectl. And from there, inside, it's just plain Kubernetes. All right. It was a quick demo. Of course, I can't cover everything inside the demo. So if you're interested in more details, please check the documentation. Last slide. Where is this being used? As Mark Rustinovic from Azure, the Azure CTO, said, the early adopters, of course, will be the paranoid and the highly regulated. So healthcare, financial industries, all of these that are regulated by their national laws. For them, it's very interesting because they can make use of the public cloud and processing data that's sensitive, that falls under these laws. And then, of course, the paranoid being like manufacturing, deploying into a factory line that's in some foreign country, and you don't know who has access to these machines, and you have some intellectual properties running there. You can protect that and ensure remotely that nobody in this factory or wherever will have access to that stuff. Yeah, and some interesting with all this AI and OpenAI hype going on. For AI and data analytics, there are a lot of interesting use cases where you can provide your models in a way that people who use that model don't have access to the model, and the other way around, right? You can provide your data to somebody that owns the model without them being able to access your data. So just some ideas of how this is already being used and will be used in the future. All right, that's it. This is all open source stuff, so you can check it out on GitHub. I've just linked Constellation, and you will find all the other stuff from there. So if you're interested, feel free. And yeah, you can reach me on Twitter, and I guess you will will know how to find me. All right, thank you.